Assalamu alaikum rahmatullah. Hello guys. Today it is a very special session because this is very practical session and today we will write naive Bayes classifier. So what we will do today? Today we will write custom Python class for classifying. We will build probability model. And I have very good dataset. And second thing, this is much more important. I checked out some YouTube videos and I couldn't find that much detailed explanation about this probability model. So I decided to do that. And in the end, if you stay till the end of this video, we will compare my model, which we will build right now, and we will compare scikit-learn implementation. I assume you know scikit-learn framework. So it's for classical machine learning and probability models. It has very good implementation, and the fact why people don't write their custom classes and why they use scikit-learn implementation, you will understood this kind of small details. I will try to show you that things. So it is very practical, and I assume that you know a little bit of Python, and I assume that you watched my previous video. So it should be somewhere recommended so that I did probability and information theory lecture, kind of lecture, and I will leave link below. You can check out, and I highly recommend first to watch that and then to watch this practical session. So let's get started. So okay, this is my screen. You can see my screen, and let's get started. Okay, first of all, I practice a little bit and I choose this data set, spam base. So okay, let's start from zero, new notebook. And if you wonder what kind of dataset we are using, so this is UCML package spam base. So we are using the dataset of this spam base UCI machine learning repository. So it's very easy to get. Okay, I think it is loading. Yeah, might be my internet is a little bit working poor. Yeah, it happens, guys. So anyway, it is loading. We will go one by one. Okay, connect. This name, like special name, we should include from scratch Python 3. Okay. So first of all, we should install this package. So why we need this package? We need this package to import the data. So I don't want to download dataset as CSV file and bring it here. So it's like not convenient. The best way is just install this package and run. Why I am using Google Colab? Easy and comfortable, and no that much problem with dependencies. And I can show you and I can share this easily, this notebook with you. So now we are importing the dataset. Okay, it's done. So let's check x. X.head means we are showing the first 3 rows of the dataset. So this is dataset. So let me talk to you a little bit about dataset background. So this is dataset of emails of 2 categories. First, spam emails. Second is normal emails. And we want to build such system which can classify given dataset, given data, or given email as it is spam email or not spam email. So in order to achieve that, we will use the simplest, the straightforward solution, probability model and naive Bayes. Here we don't have text. Here we have instead tabular form, like word frequency, word frequency of address, word address, word frequency of all 3D, the word hour, and etc. and etc. So that kind of probabilities and we have, I mean, like that kind of features we have, and we want to get the y. Y is our target. So 1 means it is spam, 0 means it's not spam, like that. So I will do a little bit of modification, pre-processing. If we check type of y, it is data frame. Okay, data frame. And I don't want it to be data frame, you know. I want it to be very simple. So y dot class, like that, if I don't mistake. Yeah, okay. Now it is, if we check y, it is series, panda series. This is better for y. Okay. We have dataset, and I already checked missing values. There is no missing values. How can you check missing values? It's many ways. Is null dot sum, and we can do dot sum. Let's check it. 0. Is null means is non value. Sum is I am summarizing everything. If there is exist any. Okay, there is no missing values, so we are good to go. Let's start. Custom class. Okay, let's name our class. Our class would be, I will say, our custom naive bias classifier. Okay, well, I will say our. Okay, so like, because it's mine and yours. So we have class, and why we use class? Because it's convenient to abstract it. So let me create init. We need init. We will initialize it, and I want it to have fit. In fit we will give x data and y target data, and I want it to return nothing, and we will give some function, and we will use predict function, a predict method. Here we will give just x, and I want this method to give me series, panda series. Okay, pass, and I wish to use some helper functions, but we will define it later. So a little bit about background. Can I show background? No. Okay, we have this one, right? See, just a moment. Okay, bias theorem is stated mathematically as the following equation. Probability of A given B is equal to probability of B given A is, we call it likelihood. That what's the probability of B event when A exists, when A occurred. It's likelihood. We call it likelihood, and I think that it's better to call like likelihood, not make things complicated. The second thing, we multiply this probability to probability of just A, and we call this as prior, and we divide this to probability of B, probability of B event. What's actually a probability of this B event occurring? And we assume that this probability of B is not equal to 0. So I think we are good to start. So I'm saying that this one is likelihood, like right? So likelihood likelihood. I will give it to none first. Self dot second one is prior. Just let me to say none for now. Self dot so likelihood, and I want to know about classes. I want to know about number of classes. Actually, what are classes? And I don't need this pass. And for likelihood, in order to calculate this likelihood, it depends. So if our data variables are discrete, we will use a Bernoulli distribution, and we will use probability mass function. Okay, I want you to pay attention. We have two ways of calculating probability. We have probability mass function and probability density function. If you notice enough that we have numbers and it is not discrete, and we will use probability density function. What is the difference between them? First, because for discrete values we use probability mass function. For continuous variables we use probability density function. So because we use probability density function, we need two more things. None. Self.mean and variance, sorry. And it means that we can calculate likelihood using these things. So it's better to eliminate. Okay, I think we are good for now. Okay, we will initialize this, guys. And we will give to this class our data. When our data is given, I want self classes. So these classes, it should get all classes name. So there is one very good method, unique. Now if I give y, it will give me only unique variables. In our case, it will return us like 0, 1, like that. Okay, we have classes. What we need? We need to calculate what are the mean variables, what are variance, and what is prior for each class and for each feature. Okay, I'm repeating. So now in fit method we will calculate mean for each class and for each feature. The same is for variance. We will calculate variance for each class and for each feature. And for the prior we don't need we don't depend on features. No, like we depend on features, and we will just calculate what is probability of that feature. We will take the number of samples of that feature. No, we will take the sum of occurrence of that class and divide that to the all numbers of occurrence. Okay, you will see how we will like as we progress, you will see that. So number of samples, number of features. How we can know that? It is, we can use x.shape. So it will return us the shape. Return tuple representing dimensionality of the data frame. Okay, we got the samples, and as I said, we need to calculate mean variable, right? We have this mean, right? Self.mean. But in our case, it is none. So before, like, I don't want it to be none. I want it to be as numpy arrays. So I will make this mean for each feature for each class as one table. So I will give here len of self.classes, and I will give number of features, yeah, and I will give this data type as float. What is this tuple? This tuple is for the shape. Can we read this? Okay, it is loading. Okay, anyway, it is very good if you read documentation. Zeros not found. np. I see, because we have an import numpy. It's okay. Import numpy as np, import pandas spd. Why we use like np spd? It is like, you know, like tradition. It's kind of tradition. Okay, here we can see like we are giving shape, what's the table, what the matrix should look like, and I am giving data type. Okay, it's saying that it is already float by default, so I don't need this one. Okay, I have for mean, and the same for variance. So variance, I want to initialize it also. It will be also lens and self classes, and it will be n features. Data type is float already, you can see that, and I don't need to initialize it. Okay, I have initialized the mean, variance, prior we will do it a bit later. No, we will do prior, yeah, right. Self.prior. For prior we only have two things. So I mean, like, it will be just array of two things, and I will give length of self classes. Data type is float. I don't need to initialize that. I think done. So now we initialized the things. What we should do is that for each thing, for example, okay, I think it's a bit unclear for you. For example, length of classes, in our case it's 2, assuming. Number of features, assume it is like 10. We will have this kind of table, and I want for each variable, so for example, this is for class 1, like we will separate the dataset of only spam variables, of spam emails from the dataset. Now, and we will check what is mean value for this feature, what is mean value for this feature, what is mean value for that feature, or we will calculate what is variance for this feature for the subtype of, for like the for the emails in the dataset which are spam or which are not spam. So we will use for index class name in enumerate, and we will give self.classes. Okay, it will return class name, right? And I will say part, no, we will say small x. How do you think if I will call small x? No, part x, part x. Part x, sub x, let's call it sub x. So what is that? Is that we will use x, and I want it y to be equal, no, y equal to class name. So what it will give? So this thing returns index number, and I assume that the index order of y column and our x data frame is the same. In our case, it is the same. So this thing is fair. So I how can I say, eliminated. So I filtered only specific class, specific data features for specific class. Okay, now we have specific class, right? And now there is very cool things with numpys. Means, let's call it means, variance, means, variance, priors, we will give index is this better, and for all feature is equal to numpy dot what? Mean. That's all. So numpy calculates the mean value for the class, for the each feature. So we will give sub x, and it's important to provide x's. X's will be 1. No, it should be 0. I think it's 0, and if it's wrong, we will change it. So what it's doing is that we are calculating the mean of given data frame in x0. It will go like row by row. Yeah, I believe this x0 is correct. So the same for variance index and all is equal to, we have this kind of wars war and if we give sub of x and x is equal to 0. Let me to think. So there are two ways of calculating np.mean arguments, average of the array elements. For example, if we have this one, if we give this one, it will return as this one. If we will give a and we will give x is 0, it will return this one. If we will give x is 1, it will return that one. np.mean a. Okay, and we have another thing. We can calculate like this, right? Anyway, we have two ways. I believe this way is correct, but like I will give like note like might be invalid. Use sub of x dot mean, and we can give x is equal to 0. This might be the solution, but I think this also kind of works. Okay, we have found successfully mean, variance, and self dot prior of index is equal to what? So we will calculate the probability. In our case, prior, it is discrete value. In that way, assuming that we will use sub of x shape dot 0, it will give us it is what? Number of samples equal to these things divided by total number. Total number is n samples, and if we use that, we will get the prior for that class, and that's done. Congratulations, we did the fit function, and now it's time for predict. So what we did in fit, we give the shape for each variable, and we calculated mean, variance, prior for each class and for each feature, for mean and variance. In prior, it's just probability of A, it's not probability of B. Probability of A is prior. What's probability of that thing occurring? Based on the total occurrence. Okay, we have that thing, and I think it's I am taking a lot of your time. Anyway, so predict. In prediction, when I checked their website, scikit-learn, and I read some Stack Overflow, they are using logarithm, and we will also use logarithm log probability. Log props equal to, we need to create another method. I will say calculate log probability, and I will give this x, and I expect it from log probability. Okay, and we will return np.series, as I said, and something blah blah blah. So def calculate log probability self, and you will get x. It should return what? It will return the frame. I'm not sure. It will return something. So log probability log probs is equal to, we will give again zeros to just initialize. It will be our x dot shape 0, and because for each sample, and we will give the self dot classes, length of classes, and I think that's enough. Yeah, we created shape of probability, and now for each class we will calculate just probability. That's all. For index, for class in enumerate, I will give self dot classes, because now I will show just what is probability of this given feature of row, that it belongs to spam emails, and our function calculate it like maybe 0.5, and the same thing we will give to and we will calculate the same thing, like what's probability of these features that they belongs to not spam emails, and we will calculate what is the probability of that. Maybe it's also 0.5. Like we will calculate for each classes. Okay, here. So for each class, and what we will calculate prior logarithm of prior. It is np.log, and we will give here prior of that index. Okay, prior of that class, it means prior of that class. Prior is just array of numbers. First belongs to first class, second belongs to second class. We calculate prior of logarithm, and now we will calculate logarithm of likelihood log. It is a little bit different. I will ask ChatGPT. So I will say log likelihood of normal distribution, show prove it from the ordinary likelihood to log likelihood, not proof. Transform step by step. So now it will show how it will calculate, like how it's like how we come to the likelihood function. Okay, here it's writing, so this is very better. So okay, this is our actually the likelihood of the given by mean and variance. We will divide 1 by divided by under the root 2p and variance, and we will use this normal e, and we will exponent these things, and we will calculate like that for ordinary likelihood. And then we will give both sides logarithm of each side, and it transforms to this thing, and from this we transform to this thing, and from here we transform to this thing, and in the end we are coming with this solution. So from this formula we are doing logarithm of z, and we are coming to this formula. And here I will put this same thing into our function. So 0.5, 0.5. So I think we are good to go. We can, okay, it's difficult. I want to make a screenshot, but it's not the same. So likelihood is that it will be minus 0.5 multiplied by np dot sum, and we will use np dot logarithm of 2 multiplied by np dot py multiplied by self dot variance of y, variance of y of idx. So if I give this thing, it will return this column, or it will return the variance for that class, for that index. I will take that thing. Okay, we have that, and plus. Okay, here minus, we can use plus, and we will use x given x minus self dot means of that index powered by 2 xi minus u. We are doing this by this way: x minus self means powered by 2. If we cover this thing, and then we are dividing it with, if I don't mistake, 2 multiplied by np dot variance of that column. 2020. This is variance squared. It is actually variance, like square. It is variance, like this sigma squared is self variance here. NP self sorry, self. Okay, I fixed one back here. So self variance of that column. So it is calculating for each feature, right? Here it's calculating for each feature, but our formula is calculating for each class at the same time, simultaneously. And we extracted minus 1 divided by 2, and if we put it out of this equation, and this one plus this one, it will be, therefore we are using plus. Yeah, and we are summing this column wise. We are summing this column wise, and so we will receive likelihood for, we will get for each feature. Okay, we calculated prior, logarithm prior, and likelihood prior, likelihood logarithm, and we calculated here for each feature. We are using that x. So here formula, we are using that x, and we are subtracting, we are minusing it with mean value, and we are giving square, and we are dividing it by 2 multiplied by variance. So this is probability density function of normal distribution in logarithm form. So we, in the end, we receive probability, likelihood, and it will be just like kind of number. And in the end, so what we will do is that we will give for likelihood like we have probes, and we will give for every feature, for each sample, and for that index for the one class is equal to, we will just sum prior log plus likelihood log. That's all. We are getting probability of this, and we are getting that thing, and we are summing that up, and we are receiving one number, and in the end it will go like that, and we will return just log props. So it will give log props. Log prop will be np.zeros, np.arrays, and it will return np.array. Maybe I can just like do like a type. Why we are using that? It's nothing, like just for fun. Zeros, 1, 2, and numpy in the array. And we are receiving that, and here we have one function like this logarithm probability. It will give us probability for each class. Like there is number of samples, and for each sample, probability of that sample is that it is spam email, it will be certain probability, and that it is not spam, that will be certain probability. And for each class, for each sample, and now we will select the highest probability one, the class which has higher probability. How we can do that? We will use we will use help of NumPy for class np.argmax and logarithm props. Select the highest one in x's equal to 1. X's equal to 1. So I believe it should work. So if it doesn't work, it's also okay. Okay, Bismillah. Okay, we got it. Our model. It's our model. Our naive Bayes classifier. Okay, so we will initialize it, and our model.fit. We will give. Okay, before giving. Actually, I don't need this one. Before giving, we will import from sklearn.model selection. I used to use a lot of these things. If you don't know, it's also okay. And from sklearn.metrics import accuracy score, and I will divide the dataset. Why divide? It's very good technique to divide it, and we can test it very easily. Test split, and we will give x, y, and test size equal to 0.3, and random state. We as data scientists, as machine learning engineers, we use random number, like random state 42. 42 is like nothing, it's also tradition. We can use your number. Okay, we have split it, right? So we will give train and y train. It will train, and I will get y predicted y equal to our model dot predict, and we will give x test, and we will receive the predicted y, right? So Bismillah. Okay, we have a problem. Our naive Bayes classifier object has no attribute prior. It's also okay. Prior, okay. It is 26. We said priors. And let's check again. Okay, we have prior. Again, prior. Where we have another thing. Another. Let's find out. Priors. Again, let's check it. Okay, I is not defined. Yeah, because it is not I. It is IDX index. Let's check it out. Okay, we have runtime division by 0 encountered in log. Likelihood log. Here we have division by 0. It's not good. Anyway, it's our model is working, guys. Our model is working. We have the predicted y. Let's delete the predicted y. So it's our model, like it's our predictions. And now we have predictions. We have actual values y test, and we can now use accuracy score to see how our model is good. Accuracy score, we will give y test, and we will give predicted y. Let's see what is the score we are receiving. We are receiving 0.79% of accuracy. So our model achieved that accuracy score. Congratulations, guys. It is good thing, and 0.79 is almost 80%. It's like better than average, right? So yeah, first part is done. So there is question, division by 0. Why there is division by 0? If we look to the formula, there is division, right? We have division. We take this number and divide by 2 multiplied to variance. It means that our variance has 0, and that 2 multiplied by 0 will be 0, and dividing by 0 is impossible. Like in mathematics, there is no such way, right? It's not the way how mathematics works. So that's a problem of traditional, ordinary calculations. So we can avoid it by giving epsilon value, by giving small value, like making 0 to like 0.1 or 0.01, something like that, that it will be a little bit higher than 0, and it will like smooth, it will overcome the division by 0 error. And that kind of small things are already implemented in scikit-learn. So this is our accuracy, right? So let's try the accuracy of the scikit-learn. From scikit-learn dot naive bias, okay, naive bias, import Gaussian NB. This is Gaussian NB because we are using probability density function that, and we are dealing with continuous variables. So sklearn scikit-learn model is equal to Gaussian. Yeah, let's recommend. Let's like after complete scikit-learn model dot fit, we will give it x train y train, and we will receive sklearn predicted y is equal to sklearn dot model dot predict, and we will give x test, and we will receive that prediction, and I will use accuracy score, and I will give y test, and I will give scikit-learn predicted recommend predicted. Okay, why? Let's do it. Here you see that accuracy is 0.82. So it's 82, we are having 79. That's difference. They are superior. Why they have better accuracy? There are some assumptions, and they are correct, that they use some epsilon value, they use some kind of small features. For example, here I checked it out, that so I took their data, took their class, and I make my subclass, and their class is not simple as our class. No, they are a bit complicated. For example, they use this kind of check no negative, check is fitted, check sample weights, check partial fit first call. They have that kind of small methods, functions around, and for each class, for each method, it is not simple as mine. So they are dealing with they are checking a lot of things. If it is first call, they will do another thing, else they will use another thing. So here they use epsilon. So I commented it out, like to check, like, what if they don't use epsilon? Will they have 0.79 as mine? No, they don't. They still have 0.82 when I checked. So they use epsilon value, and they also use update mean variance. So they update mean variance. So they have that kind of static method. Static method is the same method, but there is no, it doesn't belong to the instant of the class. It belongs to the class itself. So they use that thing, and they are saying that they did this thing based on this publication, and they are basically calculating mean and variance. Yeah, they are calculating it, and they are sometimes using average if there is some kind of sample weight, and they are combining past new. I tried to play around. I tried to play around and make like compare why they are having 0.82 and why I am having 0.79. Like, and they have that kind of small improvements, small details, like as I said, epsilon value, and they update mean and variance, not just simply calculating this thing. They have a bunch of if else and some checkings around, and by using that things they are achieving better accuracy. So I think that's all for today, guys. That's all what I want to explain to you, that we have successfully implemented naive Bayes classifier using probability density function, and here is proof, like likelihood, from likelihood we go like it's of likelihood, and it is probability density function, and for that we are giving logarithm for each side. And why we use logarithm, right? I asked ChatGPT, I made some research. We use logarithm to make numerical, to achieve numerical stability, and that kind of numerical stability, to make results stable. And if you ask what does numerical stability mean and that things, please check out my channel, please check out my playlist, and I am currently making videos, tutorials based on the deep learning book of Ian Goodfellow, and there I will explain what is numerical stability, and etc. And if you like this video, please press thumb up. So I think we will go only to webcam. Okay, yeah. So if you like this video, press thumb up, and if you have questions, please put on comments. And I hope this video was really useful and practical, because I tried to write life, not life, like I tried to write and show how it looks like, and I tried to prove like it's good to use logarithm. And in scikit-learn also they use logarithm probability, log of likelihood, log of prior. I checked it out. You can also check it out on their documentation, and if you like, you can check it out like looking to their .py files, yeah, and reading their notes. That's all, guys. This is practical session, and it is end of today's session. Have a good day. You are the best. Okay, bye bye.